Good morning. Let's start by importing a video. I'm going to use the fan card video for our demonstration today. So the basic controls are up in the upper left-hand corner. We see the control for add, okay, and the control for system. So the first thing I'm going to do is calibrate my video. It says move to known separation. So I think you can see here that there's a meter stick in the video. That's our calibration length. In the top right here it says how many pixels do you want to set that to. I'm going to say 1 meter. In fact, it's already populated with 1 meter. And for the origin, that's going to determine where my x-axis begins, and so I'm going to put that right at the yellow tape on the fan cart. So what I recommend is that you go to the settings and say for every data point that you add, that you advance the video 10 frames. You don't want to do it every 1 frame. That'll generate far too much data. So we're ready to start annotating the video now. Basically what you do is you can essentially go forward with this button here until the fan card is released, and then you click on the marker on the fan card, or basically any place on the fan card that you can easily and repeatedly recognize, and you'll see that every time you add a data point, it advances the movie, in this case 10 frames. So that's, I recommend you go more than 1 frame at a time. So what this will do is you can see that it's generating data along the graphs here on the right, and I want to talk to you a little bit about what these data graphs are actually combining. So in order to do that, you can go to this little icon here, the view options in the upper right hand corner, and you can basically turn the video off once you've annotated it. Okay. Also, what I'm going to do is I'm going to turn off my data table, so that I've got a nice big screen here showing me what the data was that I just generated. So take a look. Along the y-axis here, I've got 2 things being plotted. The position in X and then the position in Y. So back on the video, that was the horizontal and the vertical positions of my data points. Okay, and then on the y-axis, we've got time. Now for a motion like we saw in the fan cart, there was no vertical motion. So I'm going to click this button and turn off the Y data. Okay, click that button and turn off the Y data, and then that way you can really concentrate nicely on what the position of the fan cart was doing over time. You can see that there's some curvature here, and so down here, this little tool in the lower left-hand corner allows you to basically ask some questions about the data. For example, if I wanted to interpolate between the points, or my favorite here is apply curve fit. So you can see a linear fit makes basically no sense because it's not going through most of the points, but the quadratic fit applies really quite nicely, and in fact it does generate the equation for this parabola. So you can see I've got a parabola here of the form ax squared plus bx plus c, where b and c are essentially 0. Okay, now let's go to the view options again. I'm going to bring up a second graph. Now the second graph is generally set to be the velocity of the object, but you can see that it's bringing up x and y. So I'm going to get rid of that y data and I'll only have the x data. So we're going to do a little bit of analysis here with our fan card data. So the first thing I'm going to do is I'm going to give my data better names. Instead of saying x, let's call this position. And instead of saying x velocity, let's just call this velocity, so that we're not, including a lot of unnecessary information. And what I want to do is concentrate on 2 specific aspects of how these 2 things relate. So first of all, you can tell from my previous video that the slope of the tangent line was equal to the value of the velocity at any point. So the tangent line is this tiny black sort of chord, geometric chord, that's touching the curve at 1 point and at 1 point only. So let me bring up a curve that fits, and you can see that the tangent line, as we slide it back and forth, has an increasing slope. So the slope starts out at 0, and then the slope increases and increases, and the slope of the tangent line on a position time graph is the velocity. So let's take a look carefully at the data. You can see that the slope of my tangent line for this data point is 0.0579, and the velocity is 0.06. Here we've got a slope of 0.079, here we've got a velocity of 0.08, and so on and so forth. So that's some very basic sort of definitions that you will be learning in your class. The other interesting way to think about the relationships between these two graphs is that the area under the curve of the velocity graph is equal to the displacement for any time interval. So the area under the curve, so for example, let's see here, I'm gonna say what's the area under the curve bound by those 2 points? And there's a feature for that. It's called the integral. That's just a math word for area. So when I say the area under the curve, I mean if you imagine a curve that connected those 2 points, and then you calculated the area all the way down to the axis, what the computer is doing for you is finding exactly that value. So that area is 0.077 meters per second times seconds, and those units give you a really key clue. Those units have value of meters. And what that's telling us is that between these two data points, the two that correspond here, that the distance covered was actually 0.077. So let's see if that agrees. We're going to say view statistics between these 2 points on the position time graph, and you'll see, look, the delta y was 0.079, and the area is 0.077. So that is a very nice agreement that the area under the velocity versus time graph is equal to the displacement on a position time graph. Let's do another one. Let's say we go from the initial time. So I'm going to kind of draw a nice, basically you click a data point and then you drag. And I'm going to say that to have the computer compute the integral there of 0.0761 meters. So basically, if my cart started at 0, I should be able to tell that, that this data point here should be 0.671 in location. So that location is 0.755, and that agrees quite nicely. There is a small discrepancy, and that has to do, if you look carefully down at the velocity graph, the initial velocity was not 0 because the fan cart was moving just slightly when I started doing my data. Okay, that's an overview of the relationship between these two graphs.